Welcome to Palsa Lab, your destination for amazing discoveries in science, space, AI, and technology. Today, we are embarking on a fascinating journey to the very beginning, a journey that starts right now. Let's dive in.
What if I told you the next way to reach space might not be a rocket at all? Japan is working on one of the wildest ideas ever imagined, a space elevator. Not a movie. Not a prank. A real engineering concept. The plan is simple to say, but hard to build. A cable from Earth all the way into space, stretching about 96,000 kilometers. And if it ever works, it could change space travel forever. Think about how we go to space now. We launch giant rockets, burn huge amounts of fuel, and often throw away most of the hardware after one flight. That makes space travel expensive, messy, and risky. A space elevator would work differently. Instead of exploding upward, you would ride up a cable using electricity, not fuel. The company behind this concept is Obayashi, one of Japan's major construction firms. They are not just talking about a cable. They have a full design in mind: a floating Earth port, a geostationary station, a counterweight in space, and climbers that move cargo and people upward. Their long-term target is around 2050. Here is the big idea. A cable would start at a floating platform in the ocean near the equator. It would go up to a station in geostationary orbit, then continue outward to a counterweight that keeps the whole system balanced. That balance is what keeps the cable stretched tight. Once it is stable, climber vehicles could move along it like elevators on a super long rail. The floating Earth port is a major part of the plan. It is designed like a giant offshore terminal, with strong steel structures, ballast, power systems, and docking platforms. Why put it in the ocean? Because the cable needs a location close to the equator, where Earth's rotation helps keep the system stable. This is not just a building. It is basically a space gateway built on water. Now here comes the hardest part. The cable itself. The material would need to be unbelievably strong and very light. Obayashi's concept uses carbon nanotubes, or CNTs, because they are one of the most promising materials for this kind of structure. NASA's earlier feasibility work also pointed to carbon nanotubes as a leading candidate for a space elevator tether. But there is a huge catch. Carbon nanotubes are promising, but making them into a real-world cable strong enough for a space elevator is still a massive challenge. Scientific reviews have warned that defects, damage, and manufacturing limits can reduce the strength of large CNT structures far below theory. In other words, the material may be amazing in the lab, but space is not the lab. That is why this project is still experimental, not guaranteed. There is also a safety side to this story. Carbon nanotubes are exciting for aerospace and advanced materials, but health and exposure risks matter during manufacturing and handling. WHO has published guidance on nanotechnology risk management, and NIH-linked research has shown that CNT exposure can affect the lungs and skin under certain conditions. That does not mean CNTs are banned. It means this material needs careful engineering, strict controls, and responsible production. So how would the elevator actually move? Through climbers. These are special vehicles that would grip the cable and ride upward using electricity. No giant rocket engines. No clouds of flame. No giant fuel tanks falling back to Earth. Obayashi's concept describes climbers that could carry cargo, supplies, and eventually passengers to space. That is where things get even more interesting. The trip would be slow compared with a rocket, but it could be far more efficient. Instead of spending all that energy just to escape Earth's gravity, a space elevator could provide a more controlled path to orbit. Some reports on the concept say the journey to the station could take about a week at roughly 200 kilometers per hour. Slow? Yes. But for space travel, cheap and reusable could matter more than fast. And that is why people keep watching this idea. If a space elevator ever became real, it could lower the cost of moving cargo into orbit. It could help build space stations, move equipment, and maybe one day carry passengers too. NASA and other researchers have long explored the idea because the payoff could be huge if the materials ever catch up. The dream is not just about getting to space. It is about making space routine. But let's be honest. This is still a dream with giant obstacles. The cable would need to survive weather, lightning, micrometeoroids, radiation, vibration, and years of stress. It would also need repair systems, power systems, docking systems, and global-scale engineering that has never been attempted before. So yes, the idea is real. But it is still far from easy. That is what makes the space elevator so powerful as a story. It sits right between imagination and engineering. On one side, it feels impossible. On the other, major companies and researchers are still studying the pieces, testing materials, and planning the system step by step. And that makes people wonder, what if the future of space travel is not a rocket launch, but a ride? If Obayashi and other researchers ever solve the material problem, the whole game could change. A working space elevator could turn Earth into a launch platform for the solar system. Satellites, stations, cargo, and maybe even people could move upward with far less fuel and far more reuse. That is why the phrase space elevator keeps showing up in future tech conversations. It is one of the boldest ideas in modern engineering. For now, the project remains a long-term vision. But even as a concept, it pushes us to think bigger. If the cable can be made strong enough, safe enough, and cheap enough to build, then space travel may one day look completely different. Not louder. Not more explosive. Just smarter. And that is the real story behind the space elevator. Not just a cable. Not just a tower. It is a question about what humans can build when they stop thinking in rocket launches and start thinking in systems. Japan's space elevator concept may not be ready today, but it has already expanded the way we imagine the future of space travel. So the next time someone says space travel has to be expensive and explosive, remember this. Someone is trying to build a space elevator from Earth to orbit. And if that works, the sky may not be the limit anymore.